Okay, guys, I'm just trying to play around a little bit today, and you're my guinea pigs. I have a Zoom license now, so I'm going to try to Zoom the class. I have a few people sometimes that are out for COVID. It doesn't mean you're not supposed to come to class. This is scheduled, set up as a face-to-face, 2-day-a-week class. So you're supposed to be here. Can't tell you how important that is. This is really just in case somebody's home with COVID. I don't want them losing out on everything, okay? So just know that I'm trying to record things. I don't know what it's recording exactly, but that's what I asked it to do. And what I want is for it to have the gestures, but you can't read the screen through the webcam. The screen you're going to see through the screen sharing. So it should work, and I'm going to check it later today. So what I wanted to do first was just get papers back. Once more people are here, I'll run through, make sure everyone knows where they find their grades and how to keep up with things, and just make a couple other general comments about stuff, okay? So we're through with chapter 1. We're working on chapter 2 material, okay? So you saw there's a lot of homework in there, and a lot of you have really gotten in there and are working on that, okay? So keep that up, because the first few homeworks you need to have out of the way. So if you might have gotten behind if you were trying to retest, you need to get busy and catch up on that. The first 3 homeworks all pretty much go together. The first 3 homeworks are building up to you being able to handle things like this, okay? Where you have an equation like that. That's what homeworks 1 to 3. The first homework from section 2-3. That's what that's all about. Getting that under your belt. This is what everybody should already be good with today, okay, for sure. It's 2x plus 5 equals negative 13. So remember how you handle that? What would you do first? If you're trying to solve for x, you're trying to figure out what this needs to be, you got to get rid of the 2 and the 5. So how are you going to do that? Subtract the 5 because you got to undo whatever's been done. So you do that on both sides. This becomes 2x, this becomes negative 18. Okay, and then at that point, you kind of get rid of the 2. Go ahead, Tanya. Divide. And do you divide by 2 or negative 2? 2, because your goal is to make that into a 1. See, here you're trying to get rid of something that's being added or subtracted. So you're trying to turn it into a 0. Here you're trying to get rid of something being multiplied to your variable. So you want it to be 1x, so that this turns out to just be x. Keep track of the equal sign. All right, you don't want an equal here. Some of you are putting extra equals. You don't want the equal right here. You want the equal to be these spots where you're taking the original equation and you're trying to write it in a simpler and more simpler way. These are all equivalent, meaning the solution to this is the same as the solution to this, is the same as the solution to this. And then this one makes it real clear that x would have to be negative 9. So that's kind of the underlying plan. This is what the first 3 homeworks is building up to. The first one involved just adding, undoing and adding or subtracting. Second homework was undoing or multiplying or dividing. But in reality, you rarely have just one or the other. You normally have that happen, where you have both multiplying and adding, right? And you have to figure out how to get all that done. So that's kind of what I expect you to be pretty comfortable with right now. If you're not, you need to work on that, get through that today, because we have actually gone past this a little bit, if you remember. We've done the kind where you have variables on both sides, okay? So I wanted to go ahead and look at some problems that are on the skills check. Now, those of you who were retesting on Thursday didn't have time during class to do the skills check. Okay, that's in my math lab, and everybody can do it. I'm going to have it due before class on Wednesday, so that you can work on it today if you need to. But that's the kind of material I want you to have out of the way before we come together on Wednesday. Okay, you should have that under your belt. So I wanted to go ahead and look at the skills check. This was the 4th skills check, and it was on solving equations still, but it just had a variety of equations. So let's go ahead and look at that. I'm going to go ahead and use yours, Tanya. Okay.
It kind of got wet.
So the skills check 4 had 5 questions or 4 questions? 5. 5? Okay, we missed one. Nope, you just didn't number it. Had 5 questions, and they went from the one I just showed you to one where variables were on both sides to one where you had parentheses and multiple variables on both sides. So you want to kind of see that progression. So I wanted to start there today. So for instance, the first question on her version of the skills check was that, okay? Yours is going to be similar, just different numbers. Just like the example we did, what would you do on this one?
Subtract 6.
Yep. Because you're adding 6, so you're going to take away 6 because that's being added or subtracted to the variable. This is what you're trying to get on the side by itself. Have that in the back of your mind. You're not going to mess with the 48. You're going to mess with these numbers over here. So that became 42. This we did because it would cancel out and become a 0. And then this is a negative 6x. Keep track of that equal sign. Don't lose that. I noticed that on a couple where you wound up just not knowing where the equal sign was, and then you had things a little off in the final answer. All right, and we got to get rid of this negative 6. And that's because it's times. So dividing is appropriate there. So always remember, that's what you're trying to get rid of. Your focus should be on that side, getting rid of the side where the x is, getting rid of whatever is with the x. Good? Divide by, and it's a negative 6, isn't it? Because you want that to be 1. So they have to match, they have to be the same. So you divide over here by negative 6. Okay? When you do that, you get an x, and equals, over here you get a negative 7. And then you can check these. This is a skills check, so it's not going to check answer each time. So if you want to, your check would be to plug in right there the negative 7 in place of the x and see that the left side turns out to be 48. Okay, so see how that would be negative times negative, positive 42. Add 6, you get 48. We know we're right. You don't have to wait until you hit submit on that skills check. Okay, and the answer is the negative 7, not what you plugged in, not when you check. It's not the 48, it's this. Okay, so that would be what you plug in. Okay? All right, now the second one complicated things a little bit because it put a variable on both sides. Okay, so let's take a look at that. Everyone's good with this one? Got what you need? Okay. All right, so the next one has something like this. Now there's an x on both sides. Okay. So what we're going to try to do is turn this into the previous question. So you're trying to get at the end x equals some number, but we have x's in 2 places. So those x's have to be brought together, and I recommend you do that first. Okay, I know that's different than what my math lab says, but my way's better. Trust me, I've done this for 30 years, and I've seen the mistakes that people make. It's much, much better to move the variable first. So we need to get this 3x over here with this 9x, but it's not appropriate to say 12x because that's an equals, it's not a plus. So this is that barrier that if you have to pull something to the other side, you got to get rid of it there. Now, what's the sign on the 3x right now? Positive or negative?
Positive.
You're looking in front of it, aren't you? It's an understood plus. So if I want to make that go away, what would I have to do? Negative. Exactly. I would have to do a minus, negative 3x on both sides. And this approach right here is really just taking away 3x once from the right and once from the left, but I'm lining it up underneath my like term. Okay? Tanya doesn't do that, and that's okay. She winds up doing a horizontal setup, and you may want to do that as well, and that's okay. She does this. Right? It's the same thing. It's just taking away the 3x, once from the left and once from the right. So see on hers, here's the 3x and the negative 3x that are going to cancel out. And then she's going to put these together and get 6x. This approach, the vertical approach, is just lining up the like terms for you so that you can see that on the right, we just have the negative 22. Don't lose that equal sign. On the left, these are like terms, 9x. Don't put extra negatives on your calculator. It's 9x minus 3x. You can type in 9 minus 3 or 9 plus negative 3, but don't do those extra negatives in there. It's not appropriate in this case. You don't have minus and negative. It's just a minus. So this truly is just 6x. Bring down the plus 50. All right, so when you follow my recommendation of bringing the x over first, then you get that common looking equation that you can kind of relax and finish up. How do we get rid of the 50? You subtract 50 from your time. Okay, these are both negative, but we're adding them, aren't we? Mm-hmm. So in your calculator, you can type in this plus this or this minus that, but don't put in an extra negative or you'll mess it up. Then it turns out to be negative 72. Over here, we did this because it's gone. And on the left-hand side, we get just 6x sitting there. Right. Now, these problems have turned out to be nice. Integers, no fractions. When you get fractions, I do this too. I think I've done something wrong, and sometimes I have, because it's rare. They usually design the problems to be pretty nice. It's rare for that to happen, but it can happen. It won't here, though. What do we have to do next? Okay. And so when we divide by 6, we wind up with just x. And over here, 72 divided by 6, that's 12. Is it positive or negative 12?
Negative.
Because you have one negative, one positive. Of course, if you're still struggling a bit with integers on something high stakes like a skills check, use the calculator if you need to. It'll tell you whether it's positive or negative. Okay? All right, and then you can check this just like you did the others. If you wanted to, you could put in a negative 12 in here, and the amount you get on the left and the amount you get on the right should be the same. Think of it as the weight of that kid sitting on the seesaw. That's what you should think. But your answer is this. Okay? It's not what you get when you plug in. All right, so do you see number 2 is kind of a big key problem because we had more than one x. They were on opposite sides of the equal sign. So you see how we didn't get a 12. We had to move it from one side to the other. Okay? So that's very different from what we were doing in chapter 1. Chapter 1 would have had like a plus sign here, and we would have just been combining. Okay? So number 1 and number 2 are kind of the 2 key basic intermediate steps that you get to a lot of times in a complicated problem. And notice on both of these, that right there was really important. And my sense is that you're feeling okay about problems like that from the body language I'm seeing, right? This from here down for sure. So all you got to do now is work on getting comfortable with the other slight complications they're going to give you. But if you're confident here, that helps a whole lot. If you understand this one, that happens occasionally if you have variables on both sides. So if you can do that, great. Okay, so we're just kind of complicating what each side of the equation looks like on these others. So watch what happens on the third problem. All right, her third problem looks like this. All right, now this is the one that a lot of times really gets people. You have to, and this is a great one to concentrate on till it really, really, really makes sense. See, the issue on this one is we got variables all over the place, okay? The equal sign is the barrier that you don't want to cross by just pulling stuff and adding them from both sides. You have to really think hard before you do that. All right, what you ought to do before you start moving anything from one side to the other, you should get each side simplified. This equal sign isn't just between the 4x and the 6x. It's saying this whole side has to be the same weight as that whole side. So what makes the most sense to do is to go ahead and combine these. Get each side as simple as possible. Now that process right there, that's chapter 1, combining like terms. You're not gonna add the opposite, and that's the hard part for people to distinguish. You gotta understand how come we are here just gonna say negative 2x. Why don't I add 8x to both of these? Okay. Think about this. This is all over on that right-hand side over here. It's all over here. If you add 8x to both of these, can't put it below it, I wish I had written it higher. But if you add 8x to both of those, haven't you just added 16x to one side of that seesaw? You know, that's not, there's not an equal sign between these. This is really just an expression. That would actually mean you've added 8x twice to one side. That's what's hard, what you gotta work on making sense of. You've got to. If they're on the same side of this equal sign, you're just combining like terms. That's just negative 2x, period. You still have the plus 6, you still have the 6 minus 4x. Still have that equal sign. Don't lose track of where that equal sign is. But then we've got it to where we have the variables that are on opposite sides. You see that? So I love this problem for you to be able to gauge for yourself, your own understanding. If this problem makes sense, you're pretty much good to go. When there's multiple variables on the side, together with variables on both sides. If that makes sense, then you've got the difference between the two issues and you should be good to go. All right, so now we're like question number 2. Okay, I'm sorry, that's okay. In fact, I'm going to go check my programs. It'll go on in class. All right, so what are we going to do here to bring these x's together?
It would be the add.
That would be mathematically okay, but it would have the x on the right. Some people like to do that because it makes it positive. I really recommend you go bring it over here because I know we're going to do inequalities in a minute. And with inequalities, having the x on the left, you interpret it better. So same concept, but how do I get rid of that? Plus 2x, okay? So we're gonna add the 2x, and if we do that to one side, we're gonna do that to the other. Okay? All right, now, you gotta see the difference between step 1 and step 2. These were on the same side, we're just combining. We're trying to cross that wall, that barrier. We've got to do this adding the opposite to make this go away and have it come over here. It is a matter of adding the opposite. Do you see that? Okay, so now negative 4x, positive 2x.
Negative 2x.
Negative 2x. We still have this 6 right here, so I'm going to bring that down. Equals, this is gone, and we just have a 6 on that side. Okay. Now, I don't know that everybody's turns out this way, but hers turns out to have a weird solution on this one. Okay. Now, when you're looking at that, you're used to equations. The one I gave you as an example earlier looked like that. See where the x term is located? Okay. And so a lot of times people are used to subtracting 5, the second number. But see how here, this is second, so don't think you're going to subtract or add 2. Focus on what it takes to get that x by itself. You got to get rid of both of those. You don't want to divide by 2 or negative 2 right now because you potentially could have introduced fractions. So one thing that I noticed bothered people is the fact these were out of order. The best next step is subtracting 6. Subtracting 6 because right now it's understood to be positive 6. And that's the thing that doesn't have the variable on it right now. So that's what you should move next. Now, some people tried flipping this. When you flip it, this is not correct. Some people want to just say, well, let me put the x term first. That would have mathematically been acceptable to put the x term first. But the 2x had a negative in front of it, so it better still. The 6 had a positive in front of it, so it better still. Now, if you had interchanged the two terms, including the sign, this would have been okay to have done. So there's a lot of variability in the direction you can take on an equation that can still be correct. That's why occasionally I need these skills checks so that we can look at how you're approaching it, because you might be doing it correctly just differently than I am, okay? Or I might be able to catch little mistakes like that that you need to clarify. So do you see what I'm talking about? Be careful rearranging. If you pull and you rearrange terms, then make sure the sign that is in front of these stays with them. I think that was something, you gotta watch it. It's a clever thing to do. It helps at times, but only if you really pull the sign with it, okay? So if you don't, most folks don't move them around, which is great. You're gonna look at trying to get rid of the 6. And since it's positive, you're gonna add a negative or subtract 6. Anna, you with us? Okay. All right, now at that point, what is left over here on the left side? Careful,
Negative.
you're really close. The negative 2x, okay? And those little dropping of the negatives is the number one issue, okay? What about on the right?
Nothing, because you take 1 6.
But that doesn't mean the equation has been lost. Like when that happens, people lose the equal sign and then they get all confused. I still have equals, it's just equal to 0. A perfectly good number, as good as 10, okay? Leave it there, make sure you keep that equation. All right, so you see where we're headed. Gotta get the x by itself. How do we get rid of that negative 2?
Divide it by 2, negative 2.
Divided by the same thing, exactly the same, because you want it to be a 1. And then when you divide that by 2, is this one of those, some of you have done that second homework, how some turn out to be no solution, or all real numbers. Is this one of those? Did we lose our variable?
Yeah, because it's 0.
This is 0. But over here, this didn't completely go away. We still have x, don't we? So this is one that is, when you're doing your 3 dots, and filling in the answer, it's the top one. It does have a solution, it just happens to be the number 0. And so in that little box, in that little spot, they have like this going on, you would just put the number 0. It does not mean empty set. There is a solution, the number 0 will work, okay? All right, now yours may or may not turn out to be 0, but hers happens to be. All right, so this is a really good one to work on because it's not overly messy and it gets at the key mistake people make. You gotta understand when you combine and when you add the opposite. You gotta see that difference. If you're only on this side, then that's just like chapter 1. I'm asking you to simplify that. You're not moving from one side to the other. You're just putting them together and that would be negative 2. But at this point, I want to add the opposite to get the x's over to the other side. Okay, so we're using that guideline. Okay. All right, ready to try? All right, now, 4 and 5 are no big deal because they just involve parentheses, okay? But they're basically going to be just like this. Once you get it to here, you'll be good to go. This is the hard part of number 4 and 5, is making sure you distinguish these 2 steps. The parentheses usually aren't the issue at this stage. You've already been working hard on that. Okay. So number 4 should look something like this. I hate T's.
Me too.
T's are hard to read because they look like plus signs. So have a way of, when you're copying a problem that has a T in it, make a tail on it or something so it doesn't look like a plus sign, or you're going to mess up. Okay. All right, so the only difference on this one is the parentheses there on that left-hand side. But what did you learn to do when you saw those parentheses like that? Distribute. So you're going to be working on distributing here. Okay? Don't forget to distribute the 3. This 3, that's a multiplication there. It's getting multiplied by the 2 and then multiplied by this. Okay, so 3 times 2 is 6t. Here's a positive 3 and a negative 4. What's going to happen there?
So everything inside the parentheses gets changed.
Oh,
But I'm talking about the side. That's a 12.
and is it positive or negative 12?
It's positive.
But what about the fact that's positive
Well, I guess it's.
and that's negative? So it depends. Sometimes it'll change, Jordana, but this right here would have to have been negative as well. So, the sign could be both negative, this one negative, that one positive. You could have all variations. So you just let it be whatever it turns out to be. 3 times negative 4, different signs, that's going to be minus, and 3 times 4 is 12. Bring down the plus 2t, and the 24 minus t. Okay, now we're back to problem number 3. Do you see how that happens? That's why it's very important you work to understand as we go on this, that the basic one makes sense, variables on each side make sense, and then multiple variables on each side, and then you're really home free as long as you had the distributing under your belt. Okay? Now, before you start moving, it wouldn't be wrong to move the minus t and add t, but it's better to get each side as simple as possible first. So see how that has a 6t? What's the sign of that? Is it positive or negative right now?
It's positive.
Because you look in here, you're not looking here. 2t is positive. These are both positive, positive 6, positive 2t. Aren't those going to add up to be 8t? So that's really what I have on that left-hand side, is an 8t minus 12. Right? Over here, I'm just bringing down the 24 minus t. Now, what is that minus t really? How many t's is it? 1. So 1. There's an understood coefficient of 1. It's not in place of the t, it's in front of the t, kind of reminding you that's 1t that's negative, okay? All right, so now we're back to question number 2, right? Or just keep simplifying the equation. So this equation's equivalent to that one, meaning the solutions to this are the same as the solutions to that. And we just keep going until here at the end we have t equals a number. Then we know the answer, okay? All right, so at this point, I'm ready, and I have to try to get those t's together. I would like you to get used to pulling the t to the left. So what would it take?
Sure, we
Add what?
add 1t.
Yep, I need to add that 1t. So this disappears from the right side, but if I do that to one side, I do that to the other. So I keep it balanced. I keep it equivalent. So now I have a 9, don't I? A 9 of those t's. Still with minus 12. Over here, that's gone now, so I just have the 24. And now is when I usually can relax a little bit, just fly through the rest. Okay? Because it's that tight that was our goal in that first chunk of homework. What's your plan on this?
Add 12.
Because it's a minus, so you're going to add. Good. And we are working across the equal sign. Whatever we do to one side, we have to do to the other. So we're going to have that 9t, and it's going to equal 36. And so what happens now to get the t by itself? And what are you going to divide by? Yeah, positive 9. So t would equal, these are both positive, so that's going to just equal positive 4. So what I'm hoping you're beginning to feel, even if you're not quite comfortable or confident 100% of the time, is that, man, this isn't too bad. Once I got that under my belt, then I just need to understand how I handle variables that are on both sides. The trickiest step is this one, which is understanding the difference between why you get 8 here, why you just combine, but here you have to move from one side to the other. That's what I want you to really work on. Not memorizing the process, but understanding the logic of that process. Okay? Then there was one more. And hers looked like this. All right, so just another one with extra parentheses and things that you had to deal with. This one's not quite as hard as number 4, in my opinion. A little easier than number 4. All right, how would you begin when you see a problem like that? When you see those parentheses with 2 terms in them, you should be thinking distributing. Okay? So you're going to make sure you take 8 and multiply it by both of those, because that's times right there, and this is the distributive property. This is times, you're gonna take 10 and multiply by both of those. Okay. All right, so know where the mistake is typically made. It's on that second term. You've seen it happen to you occasionally. Okay, that's 10 times 2x. What's that gonna be? Okay, and then what do I get?
minus 10.
Because that's a positive times a negative. So that's gonna be negative, and it's 10 because 10 times 1 is 10. Here, everything's positive, so we don't have the sign issue. So won't that be 16x? But don't leave that a 1. That's such a common mistake. That 8 has to go to that second term. So that needs to be an 8 here. Does the 8 go to this 2? No. That parentheses shut it down, didn't it? So the distributing stops once you get to there, then you're just bringing down the 2. Okay, so far? Okay. So here we have a little simplifying you ought to do. It's these, they're constants that are on the same side. So go ahead and combine those. Now don't think this one's gonna turn out to be 0 because you see a 10 and a negative 10. Because this isn't a plus sign, so you're not combining these to say 0. Just let happen what's mathematically gonna happen. Okay, don't jump the gun. And my recommendation is to move the variable, right? Get it over here to the left-hand side, which means you gotta get rid of that. How do you?
That's right.
Subtract it, add a negative 16x or subtract 16x, because you are now trying to get across here, right? That's when the adding the opposite comes into play. So this is gone. We've just got to do that to both sides, don't we? Okay. So that becomes 4x minus 10. On this side, what's left?
The 10.
Just the 10. Okay. Again, don't jump the gun and think that's going to be 0. This is a negative and this is a positive, but that's not a plus sign, so we're not just combining those. Right, but we did get this awfully simplified, so what happens now?
You have to add 10 each time.
Yep, so now you're at that more familiar one. From here down, usually you'll feel a little sense of
Relief.
calm and relief. It's looking like a nice, quick one that you can finish up. Just still be careful about your positives and negatives. Try not to just ignore or drop those. Think how big of a difference it is to have $20 versus having a debt of 20. It's a huge difference. That's a big mistake. Okay, we only take off a point or so, you know, when we give you partial credit. Really, it should be like my math lab does and take off everything to make you stop making that mistake. It's so important you pay attention to that. So this is 4x, and it wasn't 0, was it? It's a 20 over here. And then your final step comes from getting rid of the 4. How do you get rid of that?
Divide by 4 on each side.
And so hers turns out to have x equaling 5. Okay. All right, and all of these can be checked. A lot of times, though, there are mistakes made in the check. So it's really just, if you'll be careful and organize your work so you can track it yourself. Every time I write a step, I check myself. Right, the next step, I check it. I do that myself all the way down. You can check it by plugging the 5 in. It should be in the original problem and making sure the two sides are equal. But the answer isn't what you get on the two sides. The answer is 5. So make sure you don't lose track of what you're doing if you do decide to check. Okay? So I wanted to do that. That's what skills check 4 was like. So I think I put in there about 3 attempts on that. Those of you that weren't retesting had already gotten a chance to do that in class. Some of you have to jump on this homework a little bit. Like for the first test, there's no excuse not to have done every single homework in that first unit. A lot of you skipped the one most important homework, 1-7. Never got around to 1-7. That's such a critical homework. And you had a lot of time on that chapter 1 unit to get that done. If you didn't do it before the first try, should have happened before the second try. So try to really, if you're not having enough time, you gotta find more time. Get homework done, it helps a lot. So continue coming to class like you are, and going to tutoring and all of that, but really work on that homework and work on maybe where you're doing it yourself eventually. Like you're finding that you have less and less need to jump to the example because it's clicking and it's making sense. And don't forget, you can get a red X on something and do it again. So there's no harm in trying a problem without using an example in your notes just to test yourself. You can do it again if you miss it, okay? All right, so that's kind of what you've been working on. Then we added to that the issue of the variables on both sides. Let's see if I got it here, which way I want. Okay, and I never did actually work the one that was on the sheet, but this is on the last chunk at the top. I'm gonna actually work the two that are at the top. I did examples similar, but I never actually worked those. So really, part of the second homework in 2-3, the one that had the parentheses and the variables on both sides, also includes this issue, these issues. These are special cases. Okay. And you need to see them side by side, and you need to be thinking about this. The less memorizing and more understanding, the easier it is. Okay? So these are two separate equations, but there's something similar that kind of happens on these. All right, so on the one on the left-hand side, what would your first step be?
To distribute the 2 to the 4x equal 2.
Because that's times, you have the two terms, so you're going to distribute that 4x, that 2 to the 4x and the 14. So you're going to do positive 2 times positive 4 is 8. 2 times 14 is 28. And is it positive or negative?
So negative.
Because this is positive, this is negative, so they'll turn out to be negative. Right? And then just bring down the rest of the problem. And at this point, you're ready to try to do like we've been doing, moving the variables over to the left-hand side. So I'm focused really over here. And I'm wanting to get rid of that 8x. So what am I going to do?
You would subtract the 8x.
Yeah, because it's understood to be plus, so I'm going to subtract it. And if I do that to one side, I do that to the other. Okay? But when I do that on this one, something different happens, something weird that didn't happen on all the examples I've done so far. I wanted to make that go away, and I did. I succeeded. See, that's going to be 0 times x, which is 0. This is 0, and 0 minus 28. That's just minus 28, negative 28. I succeeded. But then what happened to the left-hand side?
Same thing, got rid of it.
Yeah, you don't have an x left. 8x minus 8x happened over here. It's gone from here as well. I don't even have an x anymore. I just have this number negative 14. Okay. Weird. See, that should happen. Okay, something weird happened. Go ahead. So I was looking over here, and since it was a positive 8x, I wanted it to go away. I added a negative 8x, which did what I wanted, and I'm left with just negative 28. But then I had to add the negative 8x over here, and it knocked the variable out over here as well. And what should like freak you out a little bit is that's normally not what happens. Here's the step. This is normally what happens, right? You get rid of the variable, and when you come over here, this turns out to still have an x. These don't turn out to cancel out as well, normally, right? So that's why those are called special cases. That's weird. When that happens, it should trigger a red flag that says, this is one of those weird ones. So when you have those 3 buttons, it's not this guy, it's one of those 2. It's either the no solution one, or it's the one where the answer is going to be all real numbers. It's one of those special ones. Now hold your thought to decide which it is, because it's very logical which one it is. Let's look at this one and then compare what we get and see if you can tell me Which one means no solution? Which one means everything works? All right, so watch what happens here. When you do the same thing to start with, just distribute, because you see those parentheses. You get 8x minus 28. You bring down the other side. You may not be looking at the whole problem. You may be in that mode of just doing the algebra. That's what algebra is supposed to do, is allow you to put your mind on autopilot and you just follow the process. So if you did, wouldn't you need to get rid of this 8x right here? So you'd subtract it so it would go away. But what you do to one side, you would do to the other. And so we wanted that to happen, and it did, and we got negative 28. What's weird is it also knocked the variable completely out on the left-hand side. And we have left over here a negative 28. All right, now your answer is not either of what you see. Your answer is not negative 28, negative 14, any of that. Okay. Now you have to think about what this is saying. See, this equation right here is equivalent to that one, is equivalent to that one, and what it's telling you is this is just not true, ever. You see that? You can't make a negative 14 equal to a negative 28. This is a situation where this guy's heavier, actually. That's more negative. So that would be a situation where that seesaw is not balanced, and you have no way of making it balanced. This problem right here is called a contradiction. They wanted to throw vocabulary in there. This said equals, but it's really, there's no way to make them equal. So the formal idea here is this is a contradiction. You just didn't know it until that happened. Then you get suspicious. It's one of those special cases. And see how this right here is false? There's no way to ever get negative 14 equal to negative 28. You don't have a variable which you can plug a number in. Okay? Then that's the one where the answer is going to be no solution. Okay? But how they say no solution, keep meaning to look that up, which one they put where. Does anybody have that or remember which one's where?
The zero with the slash through it is the very last.
The last one, okay. So this is the one that has that in it. That means the solution set is the null set, which means there's no solution. So this one is the one that's no solution, is what that means. What it means, what that is called the null set. It's not a zero, it's saying nothing works. And then another way you sometimes see them talk about no solution is having set brackets with nothing in the middle. Since it doesn't mean a zero's in the middle, it means nothing's in the middle. That right there is called the empty set. Those are the three ways that you'll see them talk about something having no solution. All right, let's look at this one. So that equation is equivalent to this equation. Okay? Negative 28 and negative 28 are always equal. Okay? It's like always true. Not just in a particular instance, it's always true. This one is always false. There's no way you can plug something in that's going to make it true. Do you see the logic of why that guy over there? It's going to be the second button. And do they say infinitely many or all real numbers?
All them.
All real numbers.
Good. Okay, so what they're saying is on this one, anything you wanted to plug in is going to work. You pick a number, I plug it in, it's going to give me the same value on both sides. You know, if I put a 2 in, a negative 10, or a 100, they're always equal to one another. Okay? So you need to contrast that with the typical situation. That's when you have something like 8x minus 14. X minus 14 may be equaling 5x minus 28 or something like that, where you don't have the same variable. So when you get rid of that guy, you lose it here, but you don't lose it there. That's the normal. That's the usual case. and you get like 3x minus 14 equals negative 28, you go from there. Okay? You don't lose the variables. You see that? You still have something with an x in it. So when you work this out, when you finish this one up, you get that this one really is sometimes true. This right here is sometimes true. It's true when x is equal to exactly negative 14 over 3, and that's the only time. It's not true if you put a negative 4. It's not true if you put a 10. That's how you should think about it. So the usual case means that the equation is true some of the time. If you can find the precise number that works, that's the time it's true on both sides. It's equal. But this never can be made true. This one is always true no matter what you plug in. So those are the two special cases that can happen. Okay? All right, now look at one more part of this. If you do these problems thoughtfully, you'll know you have this situation before you get to here. Because if you'll look at it right here, see that 8x that's on both sides? That's the only variable part on both sides. So when you see that, you should be thinking at that point that you've got an 8x here and an 8x over here. Now, wouldn't 8x equal 8x all the time? No matter what you plug in for x, you're going to do it on both sides, so it's balanced. So the issue is if I take away 14 from this side, but take away 28 from that side, I'm not taking away the same thing from both sides. Do you see that? These would have had the same weight. I'm taking away less from one than I am from the other. Doesn't that throw it off balance? Yes. Makes this one heavier because I took away less. There's no way. That's not ever going to be able to balance. Okay? Because these have the same weight and then these are different. So these are not going to be able to balance. Right here, do you see the 8x? So in my mind, I'm seeing this as I'm balanced right now with 8x on both sides. See how I took away 28 from both sides?
Still balanced.
Still going to be balanced. If I put a 2 in there, I'd have 16 minus 28. That would be negative 12. But wouldn't I have negative 12 over here? If I put in a 10, I get a different number, but it's balanced. So that means it's also a solution. Okay? All right, this needs to be thought about and worked on until it makes sense. So you're not memorizing which one's no solution and which one's all reals. If you wind up losing the variable's gone, you've lost it, but the two numbers equal each other, then that means you've got that situation where the answer is going to be all reals. This is not the answer would be all reals. Okay? And then over here, your answer isn't this. You don't circle that. That's leaving me to be the one to interpret what it means. You don't circle false. Your answer would be one of these three. And this is what my math lab is using on the ones with the button. Right? You would say no solution. Okay? All right, now that's almost everything that's in 2-3. I need everybody to take out their calculators. Right? I'll go double check.
I didn't bring my calculator. I thought I had it.
Okay, so I want you to look at these problems that have maybe some decimals in them. Okay? All right, and changing like the type of number you got doesn't change the approach that you use, right? Making the numbers different doesn't change the approach. And then it used to go that way. Thank you. Did I get everybody one? Okay, so be thinking about that first question. Let me go grab some of my calculators. But listen, guys, I need y'all to get one that you use all the time when you're at home, and then bring it with you, but use it consistently. It helps you get really good at it.
This one,
Pay attention. All right, so who needs a calculator? Oh, we got one. Okay. All right. Okay, so don't let weird numbers psych you out is my biggest thing I want to say, and I mean it. The different number, the process is the same. Just weird numbers with decimals or numbers that are big or fractional. The approach that you use is no different. Unless you want to do it completely different. But normally you don't. You just approach it the same way. So I wanted to look at the decimals first because there is a method where you can clear out the decimals. But if you're using a calculator, there's really no reason to do that. Okay, so I want to show you what to think about. Okay, so that problem might at first glance look hard, but it's basically the same as having something like negative 3x minus 5 equals 10. Does that one scare you? What would you do on this one?
Add 5.
You would see readily what to do. You're going to do the same thing here. Your focus should be on working on getting this x by itself. You want to get rid of that minus 2. So you're going to add 2. The thing is, you might forget how to add 2 by hand when you're adding decimals. It doesn't become 7.7. The 2 is really 2.0 and it would line up with the decimals. You don't need to know any of that because you're just going to put 7.5 plus 2 on your calculator. So usually here it's if you decide you're going to try it without a calculator, then you got to watch it because how you add decimals is you line up that decimal points. But just do it on your calculator, you're going to get 9.5. This is gone. This still has the negative 1.5 with the x. Okay. I don't know why I wrote it off level. All right, now that number in front of the x is what we got to get rid of. So don't let it throw you that it's a negative 1.5. What would you have done if once we were to here? What would you have done to get rid of the negative 3?
Divided by negative 3.
So do the same thing here. Just divide by negative 1.5. The calculator doesn't think that problem's any harder than this one. Your brain thinks it is because the decimals make it appear to be harder, but technically it's the same problem. We're getting rid of whatever's in front of the x, we're going to divide by negative 1.5. Now what I'd like is for you to do that on your calculator so you get used to that. So this would be x, and then I want you to see, and I'd like for you to look at that and know whether it's positive or negative. What is it?
Negative.
Because there's one negative, right? Different signs. And then just do the 9.5 divided by the 1.5. See how it works on your calculator? It's really not any different than trying to do it over here, divided by 3. The calculator doesn't even see it as different at all. All right, now what happens if you do it using division is you get this. Let me do a little see that?
Yeah.
Okay.
You just erased it.
Probably just went to the next screen. Oh, where'd you go?
There it is, got it.
All right, so did you get that, where it just kept going? Okay, that's because we used division here, and this did not turn out to be a nice integer. So when we typed it in and we did our 9.5 and we divided by negative 1.5, we just got something that wasn't an integer. It was a rational number that wasn't an integer. All right, you're typically being asked to leave it as a fraction, aren't you? So if you would like, how about putting that in using the fraction keys? Remember how to do that? Okay, and then I'll tell you how to convert these. If you put in the 9.5 and then hit your ABC button, or if you have a fraction key, can you do that? Okay, you don't have a fraction key, so you just need to learn how to change it to a fraction. Everybody else should have either a fraction key. And when you use that, what happens? My calculator doesn't let me do that. Does yours? When you have decimals, does yours let you put it in? I want you to check that. That's why I'm asking.
Mine doesn't.
Yours doesn't? Okay. All right, so the only thing I have to tell you is, well, what do I do about this? I've got this decimal answer, but I need it as a fraction. So here's what you do. Take your 9.5 divided by 1.5. That's the answer, negative 6.3 repeating. But I need to write that answer as a fraction. So everyone has a key on their calculator that allows them to change. At this point, I'm using a key on my calculator that looks like this. It stands for changing from fractions to decimals. Okay. When I do that, my calculator gives me this right here. All right, so try the divided by, get the decimal, change it from fraction to decimal by choosing that button and then hitting enter. Yeah. So that was the right button, but you just got it. All right, everyone see the negative 6 and the third? See, yours sticks to fractions and then you check. Except for don't forget it's negative. Because you have one else and one zero. And you know how to change to a fraction, yours will keep it in fraction form for you. Do you have a calculator at home? Do you have one like this? Maybe use this. All right, now sometimes they say they want it as a fraction. They don't want it as a fixed number. It could be, don't give up on me, but I'll wait till afterwards, and we'll pull that up. We need to find it, because I'm sure it doesn't too.
Okay.
All right, and then if you know how to change these into fractions rather than mixed numbers, you can do it by hand. It's negative 6 times 3, okay? You do, not negative, do the 6 times 3 plus 1. But on your calculator, do you see that ABC button? Do you see above it? Above the ABC button, it actually tells you that you can change. Now, how does yours work?
No, Melody's talking how you do that.
Just to be, yep, and what you're in right now is what you really want, so yours doesn't have to go through the decimal step like we have. Okay, and then just don't forget to put the negative on it if you did like I did. All right, so did you see the button that takes like a mixed number and it has this? Something like that. It means it'll switch back and forth from fractions to mixed numbers. And so you'll finally get that. Okay, so it's just this last piece, depending upon the type of calculator you have, that sometimes you need to figure out. So that's why you want to work with a calculator that you plan to use all the time, so that you don't have to freak out when you see fractions and decimals as answers, that you can get it completely simplified. Okay? All right, so we'll try that when we're in lab, and I can help you some more to figure out how to do it on your calculator. So you'll find that decimals are not really the concern, that big of a concern, because it's so easy to do decimals on your calculator. All right, let's go ahead and do number 3. We'll skip a couple of these. How you approach the problem is the same, but make sure when you're looking at this, 5.1, make sure you see it's a decimal now, it's not multiplication. Okay. Negatives still matter just like they do on everything else, okay? All right. So what you want to do is get your variables collected on each side. You know, before you move, you want to simplify each side. And you see how over here, these are like terms, they both have Q's on them. So use your calculator to do that. The Q. Good. Wait for that Q. Good. So you guys getting a negative 2.5, and that still has the Q on it. Bring down the minus 3.5 equals negative 1.5 Q minus 3.5. Okay. Our goal is to get the Q by itself, and we got Q on both sides. So we're going to work on bringing this over to here. So how would we do that? Because it's minus, we're going to add it. Keep the Q on it when you're supposed to have the Q on it. When you're adding, you still have the Q on that. So we did it because it makes that go away. We have negative. And we have just negative 3.5 on the right side. And then on the left side, we have to do this work. So what about when you take a negative 2.5 and add 1.5?
Negative 1.
This is just negative 1 with a Q on it, minus the 3.5. Okay, so I want you to see the fractions and the decimals and not get bogged down on the factor, fractions, and decimals when you're thinking about the process. The process is the same. Whatever was here, we're going to combine, right? Because they're on the same side. So we're not thinking about how it's all of a sudden decimals. It's the same process. It's just the calculator is going to probably be a little more necessary than it might have been on other problems. All right, we're trying to get the Q by itself. What do we do about that negative 3.5?
You add it.
And this is a weird one, but is it a special case? So it's weird, I agree. That went away as well as that, but we're not losing our equal sign right now. Don't skip that. Don't get rid of this whole right side. It's just equal to 0. Over here we have a negative 1Q. Is it no solution? Is it all real numbers, or is your answer 0?
Zero divided by 1 is 0.
That's right. You didn't get rid of your variable, did you? It didn't disappear. The variable didn't disappear. If you divide by that negative 1, like she said, you're going to get 0. Q just equals 0. That's what would go into set brackets. Doesn't mean no solution, does it? Okay? Right. So decimals really aren't going to be the issue. If you'll work with your calculator, you'll feel okay about the decimals. Fractions really don't have to be an issue either. We've already dealt with several problems that had fractions in them. So I want to look at a couple of those in just a minute. Can you all do number 4 real quick? Try it on your own. I'm supposed to be able to switch to another camera, so I'm going to try that real quick. Okay, so this is that. Let me see if I can go here. Good. Okay, so let's do that. All right, so you're looking at number 4 on there. Can you just figure it out? Did you add it was a plus, right? You're going to go down to the version, you need to subtract it. Because it was positive here, and that would be minus.
I was wondering where it's coming from.
Okay, I thought I was doing it wrong.
This one, check.
And do you know how to get a decimal in one decimal? Because sometimes the calculator will keep things with fractions, and sometimes you want to have it on the decimals. So it goes like- All right, so the rule of thumb is if the problem starts with decimals, your answer is probably going to be asked for in decimal form as well. All right, so here's one approach. Let me blow that up a little bit. Okay. All right, some of you are moving the variable to the other side, so you might have something slightly different. It's not wrong. But here she distributed. You just need to be careful when you're putting in decimals that the decimal is where it's supposed to be. So it's 0.15 times the 24 should give you 3.6. 0.15 times 24 is like 15% of 24, like giving a tip to a meal that was $24. I use a lot of that thinking when I do it so that I catch decimal mistakes I might make. So 3.6 would be correct. Now that 0.15 gets multiplied by x, leaves you a 0.15, and a couple of you are losing the variable. Keep the x on it because it doesn't go with the 3.6. Then back on this side, 0.30 times 6 is 1.8. Bring down the 0.05x. Now she's noticing she's got x's in these two places, and she's trying to bring those together. Some of you wanted to move this way, and if you do, that's not wrong. But I like this approach where she subtracted the 0.15, and she's subtracting a 0.15 from a 0.05. So when you type that in, it's 0.05, take away 0.15. That decimal, moving it, putting it in the wrong spot makes a big difference. So you really should have a negative 0.1x if you moved your x's this way. If you moved your x's that way, it should be a positive 0.1x. She just brought down the 1.8, brought down the 3.6. Okay? Now at that point, her focus isn't on this 0.1 that's connected to the x, it's on getting rid of that constant. And it's a positive 1.8 to start with, so she subtracted it from both sides. And then it just happened that 3.6 minus 1.8 turned out to be 1.8. That was a coincidence. Don't lose this negative. That happens a lot. See how there's still a negative in front of the 0.1? So keep that. And now you got to get rid of that. So you divide both sides by the negative 0.1. So when you do that, depending upon your calculator, different things can happen. But what winds up happening is that becomes negative, because these are different, 18. Negative 18 would be correct. Okay. So with decimals, my recommendation is, even though we could clear them out, there's a technique for dealing with this where you clear out the decimals by multiplying by a power of 10 that it would take to move the decimal point. That is an option. So like I could multiply here, for instance, by 100, and that would move over to be 30, that would move over to be 5, that would move over to be 15. The problem with it is, it makes the numbers blow up and become quite large. So then you have the issue of really big numbers to deal with. So if you weren't using a calculator, sometimes we would clear the decimal out of there. But the standard recommendation, the approach most experts use is just work with the decimals. You got a calculator, it's no big deal. Okay? All right. Now, we've already dealt with some problems with fractions in them. So let's go ahead and go back to that and look at those. All right, so 5 is where we start with problems with fractions. I just wanted to remind you how that works. Do you remember how we did problem number 5 when we first learned it in section 2.2? Tell me some things you're doing on problems like that. You've already had that in section 2.2.
Turn into a decimal.
That would work, but not always. If this denominator were like a 3 or a 7, something like that, you'd get a decimal that keeps on going and you'd have a tendency to round where you shouldn't. So that's kind of a bad habit to change to a decimal. Here it would work because that does change to be negative 1.25, okay? But not always. How were we dealing with that before? Usually it was one of two things I saw. Isn't that being multiplied by x? Some people divide by that whole entire fraction, negative 5/4. Some people like that, okay? So that's okay. So that's one approach. Here's one approach. This works really well if you're really good with your fraction keys. So they treat it just like they would if this were 3x equals 12. When you divide by 3. And so they just say, well, it's the same thing. I'm just going to divide by negative 5/4. Now I usually have about half the class that do that. If they're good with their fraction keys, same concept, it's okay to do that.
So on the negative, is it just 5 that's negative, or is it the
It is the whole fraction, but it's not top and bottom. So that is a good question. All of these say the same thing. So think of it having one negative somewhere or out in front. Okay. All right, so you can do that if you want, and then just use a fraction key to get it. But there's a technique that we were using that makes it where you probably don't even have to use your calculator. Instead of taking care of the fraction in one step, just take care of it in 2. See, this 4 right here is really under there. It's like you're dividing by 4. How do you undo dividing by 4?
Multiply.
Multiplying by 4. So multiply both sides by 4. When you do, that 4 knocks out the denominator, which makes it no longer feel even like a fraction problem. And 4 times -10, I can do that without my calculator. And then we got to get rid of this -5 that's still here. So we'll divide at this point. All it is getting rid of the fraction in 2 steps rather than 1. This right here is actually the preferred method, and if you looked at how experts approach the problem, like after you've been doing this for a while, just about everybody does it like that. And you get x equals 8. That doesn't mean you have to, it's just an easy way to do it, so that you don't have to fumble with the fraction keys and all of that. All it is taking care of this in 2 steps. Right? And then some people even do this. They do that. They multiply by the reciprocal. All 3 of those give you 8 for an answer. This is my recommendation here. Knock out the denominator. You're done with having fractions, and then you've got something simple to deal with, and you get x equals 8 really quickly. I think that's better than these, but these are not wrong. Okay, perfectly okay. We can do that successfully. Okay. All right. But sometimes you have a problem like number 6. See how you have variables in more than one spot? Or look at number 7. See how we have variables? And number 8, variables all over the place. Get number 9. Sometimes we have things like that going on. Variables in a lot of locations. And so you want to maybe think about how to handle something like that. Okay. All right, let's try number 8 next. Oops. Pi sign for something. Okay. Fraction keys can be used. You have to orient yourself. These have t's on both of them and they're on the same side, so you could combine them using your fraction keys. Put these guys together. Just do 3/5 minus 1/10 and see what that turns out to be. And then here, what's the coefficient of t? 1. Right? And it doesn't have a t, so these are already, this side's already simplified. So using your fraction keys is one option. Using the calculator, just using the fraction keys, take that 3/5 and subtract the 1/10. So that would be what, 5/10 a half when you do it? Is that what you're getting? Did you try it?
I didn't know.
3/5 minus 1/10. It should be a half if you did it right.
It is a negative.
Did you put in a positive 3/5 and then minus 1/10?
1/2.
Because it should
I
be
did.
positive.
3/5.
That's right. But it's going to be positive 1/2.
Yeah.
Yeah, I thought you said negative.
Oh, no.
Okay. So yeah, so that's 1/2. That's with a t on it, isn't it? And over here we have 1t minus 11/2. Now this is a little unusual because it's missing a constant on this side. You know, you're used to seeing a number there, you don't. But at this point, we just need to bring those t's together.
So it's 1.
So what would we do? How would I get it off of that side?
You have to subtract this.
The fact it's got a fraction involved doesn't change the thought about what you might try to do necessarily. You just have to sometimes use your calculator or think about it. What's 1/2 take away 1 whole?
1/2.
It's going to be still a half, just negative. But the calculator can do that step for you. On the right, we just have negative 11/2.
And then you divide.
Yep, and here you can divide by negative 1/2 if you like to do that. Or you can clear out the 2 at this point if you wanted to. So what you do here at the end, like Tanya was saying, she's just going to come in and do this. You use your fraction keys. Is it gonna be a positive or a negative number when you're finished?
Positive.
And what are you getting?
11.
That's correct. And then right there, if you didn't divide by negative 1/2, you might have multiplied by 2 or something first to get that fraction out of there. And then dealt with the negative that's out in front. All right, now what you're gonna see in the example, and what we're supposed to be teaching you, and I agree with this, when you have fractions, it works really, really well sometimes to just clear out the fractions. So you don't have all of those in there to worry about. All right, so on the back or on another sheet, if you've already filled in that spot, do this one using the clearing the fractions. This is kind of where I was hoping to get to, and then I was going to try to get to lab after I got to this puzzle. Just wanted to expose you to fractions and decimals so that you feel like you can get in there and handle those without skipping them. Okay? Here's the approach that you're really supposed to try to learn. I think it is very helpful. I use it all the time. Because using the fraction keys on the calculator can be time consuming. If you understand and learn how to use clearing the fractions, it just cleans it up so it's back to things that don't have any fractions and I can deal with it much more quickly. So here's going to be the idea. Don't just look at one of the fractions. Look at all of the fractions denominators. Think about 5, think about 10, think about 2. We have an equation here, don't we? So that means we have that situation, and as long as we do the same thing to both sides, it'll stay balanced. So because I have an equation, I'm allowed to multiply both sides by something if I want to, and it'll stay balanced. So here's how I decide what I'm going to multiply by. What I'm going to multiply by is something that'll wind up wiping out the 2, the 10, and the 5 in one swoop. So like if I want to get rid of the 2 here, I would have to multiply by 2, wouldn't I? So the 2 divided by 2 would cancel out. But multiplying by 2 wouldn't get rid of the 10, would it? It's not big enough. Here I would have to multiply by 10, wouldn't I? To get rid of that 10. But I can't do a 2 on one side and a 10 on the other. It's got to be the same on both sides. So what you do is you look at these and you think that way. I'm trying to wipe out those denominators. Here it would take a 2. Here it would take a 10. Here it would take a 5. Which one of those could I use that would wipe out all of them? 10, the bigger one. That's called the common denominator. So here's the idea. We're going to multiply this side by 10. We're going to multiply this side by 10. Not just the spots with the fractions, but the whole entire side. The only reason this seems like, oh my gosh, is because it may be new to you. This actually really simplifies it, so it's worth trying to learn. Now, writing a lot of steps can be irritating. So typically when I'm doing this, I am multiplying this side by 10, but I go ahead and write that 10 distributed. You know, because we're really doing this by 10, but wouldn't we have distributed it? Right? That usually helps a little with the desire to do this process. It keeps it from being so incredibly time consuming with the steps. But you need to see that 10 there.
So you're gonna multiply the bottom and the top by 10?
But when you multiply a fraction, it's really only going to the top. Like if you do 10 times 3/5, technically you're doing 10 over 1 times 3 over 5. It would be 30 over 5, but what would that simplify to? 6. And then that's multiplying first and then simplifying. But if you multiply by 10, that's really 10 divided by 5. So a lot of times you do that process so that you simplify first, then multiply. So whatever you pick is this number that's going to cancel all these out. So you typically are thinking, well, that's 10 over 5. This would be 2. So here I really have 2 times 3t. That becomes just 6t. Just like 30, if you did it that way, that's okay too. If you did 10 times 3/5 and went through that to get 6, that's okay. But it has the t on it. Okay. But what about here? We have a 10, and here we have a 10. So what happens on that one?
That's gonna be 1.
Yep, and it had a minus in front of it, so it still does. Right? This is the mistake people typically make. See how that t didn't have a fraction? But if you didn't multiply by 10 there, you're not multiplying the right side by 10. You're picking and choosing what you're multiplying by. You're not really multiplying the whole right side. That 10 has to get distributed to everything, so this needs to have a 10 in front of it. And people don't do that one a lot of times because there was no fraction that needed to be cleared. You still have to multiply by 10. And then what does that turn into? Because 10 over 2, 10 divided by 2 would be 5, and then you have an 11, so that's 55 with a minus in front of it. All right, now, understand that it is okay to combine like terms. These are just fractions. It's okay if you want to do that. Use your fraction keys. It's just you still have fractions in the problem as you go through it. That sometimes causes people to be like thinking the problem's harder than it needs to be. But if you're comfortable with your fraction keys and you want to keep them in there the whole time, it will work. Okay? This is just the method. It's called clearing the fractions, and that's what you'll read in the text or you'll see in the examples. This is what most experts use because it just clears out all the fractions, and now, wow, that just doesn't look as hard as it used to. So I'm just going to combine my like terms. That's a 5, isn't it? So that's 5t. I'm going to move my t's together. So I need to get rid of it from one side. That's why I'm adding the opposite.
Then you divide.
And I divide by -5. That gives me t equals, and then negative divided by negative is positive, and 55 divided by 5 is 11. You'll get correct answers on math equations, no matter what route you take, as long as you do things that are mathematically valid. Okay? This would have been one, Ronald, that you could have used decimals on here, because that's 0.6, that's 0.1, that's 5.5, because they're not continuing, but just be careful. If you're going to use that, if it's like a 7 or a 3, it's going to have extra decimals, and people tend to round off and then miss. Okay? All right, that's my goal, was to get you to see that fractions and decimals don't change the approach you're going to use. You still combine, move stuff from one side to the other. It's just you have to learn to handle it on your calculator and make sure that you're comfortable using the decimals and the fractions. And don't be sloppy with those decimals. A 0.05 is oftentimes written that way to make clear that this is a decimal. Well, it's easy to see it as this, you know, to like lose those zeros. So watch that. Okay, be careful about how you type it. Okay. All right. So since we don't have much time to go to the lab, I'd like for you to try 9 however you want to. Okay? I will give you a hint. If you're going to clear the fractions, you got to get rid of 11, 3, and 5. 11 doesn't do it. It's going to have to be pretty big on that one. So it's going to have to actually be 11 times 3 times 5, whatever that is. So there's one where clearing the fractions is going to require 165. Okay? It's still doable, but you might want to play with that. How do you want to approach it? So think about that one. So work on 9 and 10. Okay. I thought it might be that one. Can you next to him? That's actually rounded, but. This one looks kind of like a financial, for financial purposes, because it has like the, R to P and P to R, and I'm thinking that's rate percent. Let me try that.
The one that you recommended we get, the one that was out. You know, the only one they had was like, well, close enough now, so I can get me that one.
Well, it won't be a problem if you clear fractions especially, but.
It won't be everything but business.
Okay, inside there. Shift it back. All right, somebody want to put up number 9 on the board? It's kind of fun to do, or I can get the overhead thing up for you if you want. We want to show it? We'll Google it before we Anybody up for doing that, number 9?
I don't have the right calculator for this. Those,
I'll write the original problem, but I'd like to try to see. Because that, this common denominator is kind of big, you may have decided to keep the fraction, that would be okay.
that's what I would have rather pay for that.
Yeah, that works. It's because that, on that one, because the denominator that it would take to clear it is so huge, you might want to keep the fractions in there. Yeah, you can do that. And then just finish it up. And get the 350, make sure you go on the 5 times 5, and it should be a nice 6. Yeah, you can do that. Just finish doing those. All right, so let's see. The least common denominator on this is kind of big. You'd have to get rid of an 11, a 3, and a 5, and the only thing that would do all of those would be 11 times 3 times 5. So 165, which would be kind of large. So let's look at it clearing it, and then we'll look at it not clearing it. It's nice to have tools when they make things easier, but it's nice to be flexible. When you have an idea that might work, feel free to do it. So if 165 is what I'm going to use, and that came from me taking 11, 3, and 5. There were no shared factors there, so I couldn't get by with anything smaller. It has to be all of that. If I decide to do this, I have to multiply both sides all the way through. That 165 would get distributed. Okay, if you want to do it by keeping the fractions, just hang on. We'll look at it with the fractions in there. Okay. All right, so like Jordana was doing this, and she's doing it right. Like right here. She did the 165 times 2, though, got 330 over 5. Just before you write that down, right there, go ahead and, if you're going to do that, go ahead and do the 165 times 2/5 and get the result all the way to the end, because if you multiply by the right thing, that's not going to be fractional when you get finished. And so she just had that middle step still in there, which is okay. But if you do that and you go one step further, you're going to see that it's 60, what is it? 66, right? All right, or when you get comfortable with this, 5 goes into 65 33 times, and 33 times 2 is 66. Getting comfortable with that just depends upon your past experience with fractions. The 165's on top, the 5's on the bottom, so it would knock out, divide 5 into that, get it down to 33 times 2, or it's okay to just do 165 times 2/5, it'll give you 66. What about 165 times 7/11? Okay. Did you divide by the 11 after you did that?
No, I think that.
Yeah.
I did 105 over 11.
And it should just be 105.
Yeah.
Okay, with no 11 underneath
Oh,
anymore.
that's
Okay, so 165 times the 7/11s. The 11 knocks out, divides into that, and leaves you with 15, and then 15 times 7 would give you the 105. And it's minus because there was a minus there.
And the last one's the same as the first one.
Yeah, notice that 2/5 and that 2/5. In fact, if we had thought about it, maybe we should have put those together like some of you did. See, you'd be flexible about your approach on this. As long as you do things mathematically valid, it'll be correct. But she noticed that's the same, she's right. So that's gonna just turn out to be 66, and neither of those had a variable on them.
So you combine them.
Over here, the 11 would divide into the 165, it would go 15 times. 15 times 4 would be 60, and it does have the x with it. Okay, it's okay to do 165 times 4, but then be sure to divide by 11 and get that result at some point. And then 3 into 165, that's gonna be kind of big. It's gonna be 55 left. And you just had a 1 there, so it's plus 55. So on this one, I think you could argue that clearing the fractions doesn't necessarily make it that much simpler because the numbers got big. Do you see that? We had to use such a big number to multiply by that it kind of gave this ugly situation when we got finished here. All right, so at this point, we have 66 in 2 places, so we'd add those. 120, 132, is that right?
Mhm.
Could be in front of or behind the negative 105. Just make sure the 105x is negative. Okay. Now we just have the variables on 2 different sides, so what would we do?
minus the 55.
You can, yeah. I'm gonna do that second. It's not wrong though, Tanya, it's just I'm trying to model the moving the variable first,
Yeah, that's true.
okay? But it's okay to do that first. So you get the 132, over here you get 165. Numbers are getting a little bigger. What happens now?
Minus the 50.
More room for mistakes because of the bigger numbers. So we have 165x. What's 132 take away 55?
77.
Really strange. All right, and then how do we finish this?
Divide.
At any time this happens to me, and I get a fraction, I get concerned that I went wrong somewhere. So I usually go back and just verify everything. All right, so we get x, and can 77 over 165 simplify?
No, this is 2 different numbers.
They are, but I wonder if there's something common you can divide out. Like does 7 go into both? Or does 11 go into both? Or put it in as a fraction and hit enter and it'll simplify it for you?
7, 13. No,
Because 11 will go into the top and give me 7, and if I do 11 into the denominator, I get a 15. And then that would be what I think the answer is. Okay. All right, so I wanted to do number 9 because I want you to remain open to what occurs to you to do. Once you have all the basics under your belt, you can approach problems in a very flexible way, using whatever makes the most sense to you. I almost always will clear fractions. But on this one, with that being such a big number, I got really large numbers in here, right? So let's do this one, and this will be the end, not clearing it. You can just watch, okay? So if we have 4/11 x, go ahead, Anna Grace, if you need to. But try to hang out here, let's just finish this up, those of you that aren't really ready to go. Let's say you weren't going to clear the fractions on this one. Then wouldn't you have noticed that these don't have x's and need to come together? And so that would have been a negative 7/11 x, and then 2/5 plus 2/5. If you needed your calculator, you could. It doesn't become 4/10, and it becomes 4/5. So use it if you're going to do the calculators, but you're not sure how they work. Use the calculator on that. If you're going to keep the fractions, make sure that you do it correctly. Okay, let's try to focus. I'm hearing too much zipping. Makes me nervous. Okay, we're almost done. At that point, I've got fractions all over the place. I'm going to wind up adding this over to here. Okay. When I do, I'm kind of lucky because the x terms had fractions that had the same denominator. Did you notice that? That sometimes impacts the choice I make on a problem. Because if these have the same denominator, it's going to be easy to combine them. They're already kind of set up, ready to go. This is gone. And a 4/11 and a 7/11 means I have 11/11. This is going to be 1 right here, 1x. Okay, that's nice. I haven't cleared the fractions, but I can live with that. I know how I can deal with them. And then at this point, sometimes I'll do that because I notice these have the same denominator and get to here, and then maybe now I might clear the fractions, but I just have to multiply by 15. Or maybe I'll continue and just subtract 1/3. So be open to those differences, and if this is not your first time, you're really good at this stuff, and you're just refreshing, have some fun with it, and think about, well, what's a neat way I could do this? What's a different way? What's something I could try? All right, so here, this is gone. We get our x, and then it's just a matter of doing 4/5 minus 1/3, but you better use your calculator and not tell me that that's going to be 3/2, because that's not how fractions work. If you're doing that, the mistake people make is 4 minus 1, 5 minus 3, and that's just not how it works. Fractions have to have a common denominator. So use your fraction keys to do that. And when you do, you'll wind up getting the common denominator here. So you'll have 12. It does it for you. You don't have to actually do this. But it does that behind the scenes, and it'll tell you 7/15. Okay. So on this particular problem, that actually may have been a pretty efficient approach because these had the same denominator. So when you combine them, it kind of worked out pretty well. You see that? And then if I want to keep the fractions, I can, or if I want to clear them at that point, I can. So just understand, with equations, you have a lot of options. Because as long as you're doing the same thing to both sides, and not dropping signs and all, it should work. All right, so you've got some work to do. Everybody needs to be sure that they're finished with the homework 1, 2, and the 2 homeworks on section 2-3. That's the one with the variables on both sides and parentheses and special cases. The fraction and decimal homework has been open. You need to get started on it. And don't let those fractions and decimals psych you out. Once you've done that, that is the most important thing we do in this class, section 2-3. Getting good at solving equations confidently, okay? So work really hard on that for me. Skills check is in there. So you have 3 tries on that. Try to just get it done outside of class, but bring your work to me on Wednesday. Okay.
changing signs.
Yeah, I did it to you, change.
But you really, if you kept change here, you kept change that to minus, and that would become negative on the other. So you really don't need that keep change except for when it's a minus. Like minus and negative or something like that. So it works here, it's negative, minus, and negative, so you change it to plus, take the opposite, and that becomes 10. So that would be equivalent. So like here, it's 9 and 7. Just think 9 plus negative 7 is negative 2. So that's 16 plus negative 2. When you keep change, you can get lost on where your signs are. So this was, I mean, that was a positive. And then it was just 16 plus 2. So if you're using keep change, because you start introducing extra negatives. And then here, you have negative times a right? It's going to become plus. This is okay. Minus negative 50, but if you do minus negative 50, it becomes plus 50. So that's the part that you got to get. Which is notice in some of these extra signs, not notice where it might not be helpful. When you do it, when you have like a minus, you want to change that. But if it's plus already, then that's what you're going with. So then you've got that. But they're really pretty good. More time for homework. I'm gonna make sure you get through that. Did you want to check this out?
Yeah.
Laura?
If you got a second, let's
Oh, yeah.
let's Google that. Okay, let me see now. If I undo this, stop sharing, turn off my screen